Hello, welcome back to the latest edition of Algebra 2A. We are looking at lesson 12 today. Our learning target is to solve problems involving inverse variation. So we will not be doing joint variation, only the inverse variation. An inverse variation is when the product of variables x and y is always a constant k. So back in lesson 8, you looked at direct variation with the quotient of x and y, so y divided by x always gave you a constant k. Here we're looking at the product. So when you multiply x times y in each ordered pair in your relationship, you're always going to get a constant k. We were introduced to direct variation in lesson 8, and we saw that when we're looking at an x and y variable relationship, that as the x increases, the y increases. As the x decreases, the y decreases. And then every time we found an ordered pair and we took the ratio y divided by x, we always found that that was a constant k, called your constant of variation. Well, today we're going to look at what happens with an inverse variation. So to explain inverse variation, we're going to look at a situation. So let's say you were tasked with a job. So possibly you were doing a favor for your neighbors, or you have a chore to do with your parents and they ask you to rake your yard and it takes you 8 hours to rake. If you do that by yourself, so if there's only one person, so we're going to put a 1 for x, that's going to take you 8 hours to do it all alone. But you're going to work smarter, not harder, so you call a friend. So now you have 2 people working. So technically, if 2 people are working, splitting the job, how many hours will it take? It now will take 4 hours. But you're going to work even smarter. Each of you call another friend. Now you've got 4 people working. If 4 people are working, doing the equal amount of work, it should now take you 2 hours to rake your yard. And lastly, if you each decide to call another friend, now you've got 8 people working. 8 people working on an 8-hour job should only take 1 hour each. This is now an example of a inverse variation. And some things to notice as you're going down your table. As the x increases, you can check over here what's happening to your y's. The y's will decrease. And as you start to decrease your x, so that would be less people working on the job. As you're decreasing the x, what would happen to your y? Your y would start getting larger because it takes more hours to do the job. And the last thing is we can find the constant is going to be by taking the product of your 2 variables. And if you look, you take the product of 8 and 1, that's going to be 8. 4 and 2 is 8. 2 and 4 is 8. 8 and 1 is also going to be 8. So no matter how we multiply our variables, we're always going to be left with the total amount of hours it would take you to rake your yard. So the x's, as they increase, as the more people are working on that job, that's going to cause the time of the job to start to decrease. So we start to see that inverse relationship backwards from how direct variation works. To write an inverse variation into function form, they're all going to follow the same model. We're going to take y equals our constant, and our constant in that case was the total amount of time it takes to rake your yard divided by x. So this example that we just did over here would be y equals 8 divided by x. So take the total amount that the job is going to take, divide by how many people are working. That'll tell you your y, the amount of time the job will take. So when looking for a inverse variation, we're going to see our constant is always going to be divided by your input. So a helpful thing to put in your notes would be the direct variation form compared to the inverse variation form. So looking at the equation forms, that's what we're looking at to distinguish between a direct variation and an inverse variation. So in problem 1, we see some data in the table that represents this equation, y equals 8 divided by x. And this one looks a little familiar. Part A says, is this equation an inverse variation? If so, find the constant of variation. So the answer to that is yes. Our constant 8 is being divided by x. That would be a inverse variation, yes. What is the constant of variation? K is going to equal to 8. Next, what will the value of y be when x is 16? So we can put in 16 into our equation. So thinking our example above, this would now be of 16 people, so 15 friends helping you rake your yard. You take the total amount of time it takes to rake divided by 16, and that means that it should take you 1/2 of an hour. So that would be your result. If you had 16 people working, it would take a 1/2 hour to rake. The second part of our learning target, so we've talked about what an inverse variation is. Now we're going to start to practice how do we know if it's an inverse variation or a direct variation. The first thing you're going to look for is how your x and y's behave. So you're looking at your x's as you go down the table, your x's are increasing. Then you take a look at your y's, and as you're going down the table, you're checking your y's are decreasing. So this right now is possibly an inverse variation. The only thing we have to check now is the constant y times x always going to be consistent? So we're going to take a second, we're going to multiply each y and x, see if we get a constant value. So first we can multiply the 2 times 6. 2 times 6 is 12. 3 times 4 is also 12. 4 times 3 is 12. 5 times 2.4 is 12. So I'm looking for that constant and seeing if I get a consistent value each time. Yes, so it is a constant of 12, so my k is going to equal 12. That now means that I can write a inverse variation, y equals my constant 12 divided by x. So there's my inverse variation. Recall I'm multiplying the y and the x to find the constant, but then my inverse variation form is y equals k over x. In part 2, we check again how are our x's behaving. X's are increasing. How are the y's behaving? The y's are increasing. So going back to our previous page in our notes, this is going to mean that we have as x increases, y increases. This is going to mean that we possibly have a direct variation. So we have to check to see if we can find a constant. To find a constant, we're going to check to see, do we get a consistent value, constant value, every time we take the y variable divided by the x variable. So we will check that. So we'll take our y over x. 6 divided by 3 is 2. 8 divided by 4 is 2. 10 divided by 5 is 2. 12 divided by 6 is 2. So that does tell us that we do have a direct variation where our constant is equal to 2. And to write a direct variation equation, we're going to put it in the form y equals kx, which we now know the constant is 2, so y equals 2x. So in lesson 12, we looked at the definition of an inverse variation, and hopefully that example about the man hours and dividing it up among friends starts to decrease the amount of hours. That's what we're looking at when we see an inverse variation. So inverse variations, you'll see one variable increase while the other decreases, whereas direct variation, like we looked at in lesson 8, as one variable increases, the other also increases, and vice versa. As one decreases, the other decreases. So there you have it. There's lesson 12. Thanks for joining, and you are now ready to do your practice. Good luck.